So I wanted to point out one more thing. I've been really hammering it in that when you multiply by something with a variable, you might create fake solutions. When you divide, you might remove actual solutions. But what about squaring both sides of an equation? What might happen then? Let's look at a really simple example where we would never actually want to square both sides, but maybe doing something really easy to start us off will illustrate what's going on. Suppose I just said, hey, I have no idea how to solve this equation. I'm going to just square both sides. I mean, the left is equal to the right, so if I take the left and square it, that has to be equal to what I get when I take the right and square it. So this implies this. And then I can do this and subtract that 4. And look at what we get. See if we can factor this. Maybe it'll have some solutions in the whole numbers. Well, I need to use a 3 and a 1. And I want a plus 2. I'll get that from a plus 3x minus 1x. Okay, so I get two solutions. X equals 1, or the other solution is x equals minus 3. I probably should have written this first. Just to make sure you're all following. But of course, if x minus 1 is 0, then x is equal to 1. And if x plus 3 is 0, x equals minus 3. So two solutions, 1 and minus 3. Let's look at this original equation. Well, 1 works very nicely, but what about the minus 3? What would happen if we plugged minus 3 in here? We would get that negative 2 is equal to 2. Is negative 2 equal to 2? No. So why are we getting it? Well, remember we squared both sides. And if you square both sides of this equation, we're sort of asking for, this was a 2 here, solutions where if we square the left, we get the square of the right. And negative 2 actually works perfectly for this situation, because if I take negative 2 squared, I do get the right-hand side squared. So this fake solution, negative 3, does satisfy left-hand side squared equals right-hand side squared. But remember, for any positive number, there's going to be a positive and a negative if we take the root. So we created a fake solution. In a sense, we did multiply by something that contained the variable, because we're squaring both sides, and squaring the left-hand side, you could think of it as falling under the same situation. Or you could think of it as a different situation and just be careful when you do it. But this is one thing that could happen. Now, you're probably thinking, okay, I'm ignoring everything you just said, because I would never look at this equation and decide to square both sides. Okay, but there are going to be some situations where you are going to want to square both sides, because it'll make things much simpler. And when you get to those situations, you still have to be careful of this same thing, creating solutions that don't really exist. So, to summarize it, you could think of it as 2 rules or 3 rules. Try to never divide by something with a variable, or multiply by something with a variable in the denominator, if it's a rational expression. So just don't divide. But if you multiply by something with the variable in it, or if you square both sides, you might be creating extra solutions which don't really satisfy the original equation.